Next, we're going to take a look at creating box plots, which puts the 5-number summary on a number line. So I have two sets of data here for you. These are test scores. We've got set A and set B. And what I did was I already found the 5-number summary for each set so that we can focus on creating the box plot and interpreting it versus finding the 5-number summary like we saw in the last video. So I am going to label my number line down here. I notice that the smallest minimum value is 46 and the biggest maximum value is 96. So my number line needs to go from 46 to 96. Next, I'm going to put each set of data on the number line. I'm going to put a dot for each of the 5 values, and then I'll create my box plot. So I'm going to do set A on the top. So I'm going to go a little higher for that one. So 48, 78, 92, and both the third quartile and the maximum value for this data set are 96. So this is not going to look like a typical box and whisker plot. We're going to have a box around the first quartile and the third quartile, and then we do a vertical line through the median, and then typically you would see a whisker to each end, but we're only going to have one whisker on this data set because of the third quartile and the maximum being the same value. Alright, so now we're going to do set B. So we're going to plot those 5 numbers again. We've got 46, 61.5, 73, and 83. And the maximum is 96. I forgot it in my first list of numbers, so I got that added. This box plot will look a little bit more traditional. So again, we've got that box around the first and third quartiles, vertical line through the median, and then whiskers to the maximum and the minimum. Make sure when you're creating a box plot that it has a title, and if it's a comparison box plot that you have a label for each of the boxes. So our title would simply be test scores. And we're going to talk a little bit about what each of these boxes show us. I also want you to know that these test scores are from my pre-calculus classes. There were a couple I had to grab from my algebra class just to even out both sets, but I divided the class into 2 groups based on a common characteristic. So I'm going to see if you can think about what that common characteristic might be, and we'll talk about that in class. So first of all, noticing the test scores for set A. In general, set A had higher test scores. So remember, a box and whisker plot, that 5-number summary, divides it into 4 equal data sets. So real quickly, let's remind ourselves on this example that we had 4 data values in each grouping. So this first data set would be the whisker from the first quartile to the minimum. This one right here would be the first half of the box from the first quartile to the median. This one is the second half of the box, and this one would be from that third quartile to the whisker, the maximum. So there's 25% of the scores in each part. Now remember, when you're looking at a box plot, if the whisker or the box is longer, it does not mean it holds more data. That's a really common misassumption that students make about box plots. What it means is that the data is more spread out, it's more diverse, it's more different or dissimilar from one another. If you have a small box or a small whisker or a non-existent whisker, it means the data is exactly the same. So in the case of set A, 25% of the students scored 96 because there is no upper whisker. It's equal to that third quartile. So we've got a really short upper box. It means all of that data is really close together. So 50% of the students in set A scored 92 or better, looking at that median. So there's our median value of 92. 50% of the students scored a 92 or better. Again, think about what that common characteristic might be, that 50% of students in that group scored an A on the exam, and this was actually the last test, Unit 9A test. For set B, looking at that median, the median value was 73. So 50% of the students passed the test with a C or better, which is proficient, which is good, but it's certainly not half of that group getting an A. And then looking at this whisker For set A, it's really long. That could tell us there might be an outlier for this data set when that whisker is so long and the top part of the data is so clustered together. And when you look at those actual test scores, 48 is definitely an outlier. Another way that you can see outliers on a box and whisker plot, if you go through the formula to find the outlier, is with a little asterisk. So this one could also look like 72 would be the minimum without that outlier. So this would be the whisker. The rest of this whisker wouldn't be there, and you would just see like a little star at that 48 where the outlier occurred. Looking at that data, the box plot without the whisker, 100% of the students scored with a C or better. For set B, you can tell the data is a fairly similar spread. So when you look at each whisker, so our first whisker, our first box, second half the box, and our last whisker, they all look like they're about the same length. So what this says is that the spread of the data is fairly consistent. Some of the students did well, some of the students did not so well, but the test scores are kind of spread out in a similar manner, whereas in set A, they're all clustered towards the top part of the graph. Now we're going to look a little bit more in depth at comparing two box plots. So we've got Irene and Gregor spending money at a restaurant, at different restaurants last month. And again, as I mentioned before, those little asterisks or the stars represent outliers. So our first question is, who has a smaller range overall? When we're talking overall, we have to include those outliers. So Irene's range with the outliers would be 120 minus 0, so that gives us 120. Gregor's range with the outliers is 140 minus 10, so he has a range of $130. So obviously Irene has the smaller range overall. And then looking at the data excluding the outliers, so Irene's new range without the outliers would be 70 minus 0. And Gregor's range without the outliers would be 50 minus 10, or $40. So without the outliers, Gregor's range is smaller. So there's without and there's with. What percent of each person's data is less than $40? So when we look at our graph right here, we've got our $40. For Irene, that's her median. So that means half the data, or 50% of her spending, is less than $40. For Gregor, that was his third quartile. So 75% of his spending is less than $40. Now, as a reminder, each of these pieces of the box plot contain 25% of the data. The quartiles split it into 4 equal pieces with 4 equal amounts of data. So again, looking at Gregor's box plot, excluding that outlier, his data looks really similarly spread out. All of the whiskers and the boxes seem like they're about the same length, so their data is clustered closer together or in similar manner, whereas Irene's, this 25% of her data is much smaller, as is this one, again not including those outliers, whereas the first 25% and the third 25% of her data is a little bit more spread out. Finally, which person has less variability in their spending habits? This is what box plots are really good at showing. I've been trying to talk about the spread of the data and the length of the box or the whiskers, and that shows the variability. So when you look at a box plot, as you can see, Gregor's is clustered really close together. Not only does he have a smaller range, he's got a smaller IQR, and each piece of his box plot is smaller. All of that points to his data being less variable. It doesn't change as much as Irene's. Irene seems to go to some restaurants that don't cost a whole lot of money. So when we look here, she spent $0 at a restaurant. She must have had somebody pay for her. And then all the way up to, again, excluding those outliers, $70. That's quite a bit of money to spend at a restaurant. Whereas all of Gregor's, except for that outlier, is between $10 and $50, much less variable, much more similar types of restaurants that he's going to as far as cost, versus Irene seems to have a wide range of spending habits at restaurants. All right, and for your U-Try, I'm going to have you create a 5-number summary, and then together in class we can look at creating a box plot for it.